Lesson 2.0 Acids and Bases. Acids are chemicals that turn the well-known indicator litmus from blue to red. They conduct electricity when dissolved in water. They react with metals to produce hydrogen gas. They taste sour, such as the acid found in lemon juice and in vinegar. Chemically, acids are aqueous solutions of ionic compounds whose formula starts with H, the hydrogen ion. Examples are HCl, H2SO4, and HC2H3O2. All of these compounds are ionic. They start with the hydrogen ion, which is acting like a nonmetal, since it's found at the beginning of the formula. So all of these as dry chemicals are crystalline structures. The first one is hydrogen chloride, the second is hydrogen sulfide, and the last one is hydrogen acetate. When we mix these with water and they become dissolved, they become hydrochloric acid, sulfuric acid, and acetic acid. Acids must be dissolved in water. The term is they must be aqueous. Bases, on the other hand, turn red litmus paper blue. They also conduct electricity when dissolved in water. They are slippery and bitter tasting, like baking soda and soap. Chemically, these are aqueous solutions of ionic compounds that end with the hydroxide ion, the OH ion. Examples of these are NaOH, MgOH2, and CaOH2. These are ionic compounds. They start with the metal, and they end with the hydroxide ion, OH. So as dry chemicals, these are also crystalline solids. However, when you mix these solids with water, they become bases with qualities that we stated earlier. Their names, however, do not change. Rather, we just add the word base to the end. So these are sodium hydroxide base, magnesium hydroxide base, and calcium hydroxide base. Neutral substances are compounds that are neither acidic nor basic. These include ionic compounds that do not start with the hydrogen ion, or those that do not end with the hydroxide ion. For example, NaCl, MgCl2, and FeSO4. They start with the metal, and they end with the nonmetal, which indicates that they are ionic, but they do not start with hydrogen, nor do they end with hydroxide. These three are examples of neutral ionic compounds. The pH scale is a system where values is assigned to acids and bases to indicate their strength. The scale ranges from small values near 0 to large values approaching 14. On the left side we find the acids, on the right side we find the bases, and the middle are the neutral substances. pH values less than 7 indicate an acid. pH values greater than 7 indicate a base or an alkaline substance, and pH values equal to 7 is neutral. This table shows the relative strength of acids and bases. On the left side we see milk is acidic with a pH of 6, while lemons are acidic with a pH of 2. These values indicate that the acid in lemons is stronger than the acid in milk. On the other side we see a base found in soap has a pH 10, while the base in oven cleaner is near 14. This indicates the oven cleaner is a much stronger base than the bar soap. It is more alkaline. pH is a measuring system based on the power of base 10. pH 6 is an acid, while pH 3 is a stronger acid. But how much stronger is it? Is it 2 times or 3 times? Well, actually, it's 10 to the power 6 minus 3. It's 10 to the power 3, or 1,000 times stronger. pH indicators are chemicals that change color when exposed to chemicals of different pHs. They can be used to estimate the pH of unknown chemicals. Some examples are litmus paper, which turns red in acid and blue in base; bromothymol, which is yellow in acid and transitions to green to blue in base; and phenolphthalein, which is colorless in acid and turns pink in base. There are many other indicators, such as methyl orange, methyl red, and indigo carmine. These different indicators can be used in combination to narrow the pH of an unknown by looking at the results from all the different indicators.